Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappin'? Today we are going to look at series circuit practice problems. And by problems, I mean we're just going to do one together. So here we have a circuit with two resistors. We have a 9-volt battery. Resistor 1 is 20 ohms, and resistor 2 is 15 ohms. What we're going to do is set up a VIRP chart right here to help us analyze a circuit with multiple resistors, in this case a series circuit. So the first thing we're going to do is just label what we have. So we know we have a 9-volt battery, so that goes under total, 9 volts. And then we have R1 is 20 ohms, and R2 is 15 ohms. And from this, we have to figure out what to calculate right away. In this case, the first thing we're going to do is, since we know R1 and R2, our first step is to calculate R total. So we look at the relationship in our reference table for resistance in a series circuit, and R total is equal to R1 plus R2. In this case, 20 ohms plus 15 ohms gives us 35 ohms. So R total, 35 ohms. Okay, now that we have R total filled out, we know the total voltage and the total resistance, so our next step is to find the total current. To do this, we're going to use Ohm's law. I total is equal to V total over R total. And then we just plug and chug. I total is 9 volts over 35 ohms, and that gives us 0.26 amps. So we know our total current is 0.26 amps. Okay. Step 3. Let's now look at the current for a series circuit. And we know the total current is equal to I1, which is equal to I2, because they all follow the same path. So we know the current across resistor 2 is 0.26 amps, and the current across resistor 1 is also 0.26 amps. Alright, that was easy. Step 4. Now we know the current through each resistor and the resistance of each resistor. So let's find the voltage across resistor 1 and 2. We'll go back to Ohm's law. I1 in this case is equal to V1 over R1. Solving for V, so multiply both sides by R. I1, just kidding again. V1 is equal to I1 R1. I1 is 0.26 amps, and the resistance of resistor 1 is 20 ohms. Plug and chug, we get V1 is equal to 5.2 volts. And we do the same thing for V2. V2 is I2 R2. In this case, we get 3.9 volts. Now, V1 plus V2 should equal V total. In this case, we get 5.2 plus 3.9, which gives us 9.1 volts. And that's because I rounded the current up. Okay, now the last step is the power. Now we have a lot of options for calculating power. I'm going to use P1 is equal to V1 I1. So P equals VI. So for resistor 1, we know the voltage is 5.2 volts. And the current is 0.26 amps. And we get P1 is equal to 1.35 watts. 1.35 watts. It's a 5, sorry. Doesn't look like a 5 still, but sorry. And then P2 is equal to V2 I2. And we plug that in a calculator, so we get 1.01 watts. And then P total is equal to V total, I total, which gives us 2.36 watts. And that's it for me today. That's how we analyze a series circuit with multiple resistors. Hope you found that useful. See ya.